Assalamualaikum, Bismillahirrahmanirrahim. Today we are going to learn how to draw very complex molecules. A friend of mine sent me this structure and asked me how can you draw it in Gaussview. Uh, if you want to run some computational stuff on this kind of structure, how will you start? Drawing these kind of structures is not that simple, and it takes a little bit of effort, but I'll tell you the way how I would do it. You may find another way or a simpler way for it, and it's up to you guys. Uh, if I would start this structure, I would first of all, you have a look. This is open in ChemDraw, and I have shown the stereochemistry so that the stereo centers are highlighted, and you know that. Which stereo center is S, which is R, so that when you make in the Gauss view, you make the right stereochemistry. You don't make the wrong one. So first of all, let's start with this structure, with this ring, which is the central ring where all the things are attached. Uh, for this kind of structure, you also need to have a little bit of chemistry in mind. So this is a six-membered ring, and this six-membered ring is not aromatic, so that is very important. We cannot start with an aromatic ring. Instead, we'll start with a six-membered cyclohexane ring and try to fit all the other things in there. So if you select the ring option in Gauss view, you can see that we have a six-membered ring over here. So I'll select this one and just draw it. Now here is the ring. I'll just put it in the style I can see in the ChemDraw. So first of all, there is a double bond between these two carbon atoms, and there is an oxygen here. So what I'm going to do is remove this hydrogen. So I'll make this atom as oxygen, and then I'll create a double bond between these two carbons. But to create a double bond between these two carbons, I need to remove their hydrogens so that they can be adjusted in proper angle afterwards. So I'll just select the bond option and create a double bond in here, and then I'll select the atoms, oxygen atom, and replace this carbon with oxygen. So now if I add hydrogens over these two atoms, and at this stage I can also clean this structure a little bit. So there is an option of clean in Gauss view. If I click this, it will make the bond angles right for these two hydrogens. So now this ring is almost complete, and we forgot to remove one hydrogen. This hydrogen should not be here. I'll clean it again. So it just cleaned it a little bit more. So now this structure is okay. Let's move on. So here is a hydrogen that is above the plane, and then you can see another oxygen that is also above the plane. So if you look at this, you at the bottom carbon, what I'm going to do is add an OH group just right here above the plane. So consider this is an OH. At the moment I'll add OH, and later on I'll add a sugar molecule like this one to this H. So basically the thing is that you make the right stereochemistry. So it is above the plane, this one, and I made this bond above the plane and left the below the plane hydrogen over there. And now this hydrogen, this one, this is above the plane, and the CH2 group is below the plane. Now what I'll do is I'll select a CH3 and add it below the plane. So this atom is above the plane because you can see it's above, it's towards you, and this is below. So I'll change the below atom to CH2 group. And now after CH2, you can see that there is a carbon it's a carbonyl carbon. So I'll try to add a carbonyl carbon directly from here. See, I have added a carbonyl carbon, and that after carbonyl carbon, there is an oxygen C double bond O and then O, and then there is a CH2. I'll select CH2, again a CH2, this CH2, this CH, it's not CH2, it's CH, but at the moment I'm going to add a CH2, and then at the end we'll put an aromatic ring over here. Now there is another thing which needs to be taken care of, and that is this double bond. You see, this double bond is uh, right at this junction, and to create a double bond, I believe we need to remove this hydrogen as well. So now this carbon has a hydrogen, and I'm going to create, I'm going to add another carbon, and then I'll add a double bond here and then another carbon like this. This is a CH3, and this carbon has a double bond. So at the moment I'll not add the CH3, rather I'll just leave these hydrogens over there and create a double bond between this carbon and that carbon. Now if I clean it again, it tried to clean it a bit, but still you can see that this hydrogen and this oxygen is, they're very close to each other, and soon we're going to optimize them so that they can get a bit far away and to the proper position where they should be, where the repulsions are minimum. Now there will be another problem. This sugar molecule is the biggest problem, I believe, in this structure, because it will become a very strained kind of structure if I add this sugar and connect this position to that position. So let's try to do this at the same time. Uh, One thing is that I can go and optimize the structure. Let's give it a try. So if I just optimize this structure with the simplest method, and I'll just add SCF is equal to XQC, edit, save, and just name it 123. Let's run the calculation and see how it goes. So calculation is finished, and if I close it and open the log file, you can see that the molecule is optimized, and it looks much better. It looks quite good. So what I would do is, now there are a couple of more things to take care of, like this COOCH3, and then the most important thing I think is the sugar molecule. So I'll just take a new file and try to make the sugar, and then take this sugar, copy it, and then add it to that molecule. So I'll try to make exactly a sugar like this one. So if I make it like this, it should be this way. Yes, so this is an OH. I'll just add OH, OH over here, and then OH over here, and then OH or axial position, this OH also axial position, and then there is an oxygen atom this one over here, and these two hydrogens don't exist. And after that, there will be a CH2OH over here. Let's select a CH2 that will go to this position, this one, and then OH. So this is a sugar molecule. Let's optimize this one, and then after optimization, we'll take this optimized molecule and copy it to the original structure and try to join the two. So just sugar. So I'll copy this structure and paste it into a new file to make the structure proper. So now I'll try to fit the sugar molecule over here and join this position with that one, this one with this one. And I believe that will be a little bit of tedious step, but hopefully we'll do it. Yes, the calculation is complete, and I open the log file. You can see that this sugar molecule got optimized. All right, so I'll just take this one, copy it, and paste it here. Now the tricky part would be to join it. So if I want to just move one molecule, I press the alt key on the keyboard, and it will allow me to only rotate this sugar molecule instead of rotating the whole molecule. So let's first make it into the orientation as it is in the chem draw. This one, that oxygen is behind the plane, and then this hydroxyl is below the plane, and this is above the plane. So now I have to join this atom here and that atom over here. So let's move it. If I press Alt and Shift and click this molecule, I can move one molecule at a time. So now I'll try to rotate and bring them closer and closer so that I join them the right way. This oxygen is quite near now, so I'll just put it over here and move it a bit with pressing Alt button. And now you can see that this oxygen is very near to that oxygen, so I'll just remove this one and the hydrogen as well and create a bond between this atom and this atom. All good. And then this oxygen OH, CH2O, and then carbon. So I'll just remove one hydrogen from this carbon and one hydrogen from this oxygen and create a bond between the two. Here we go. This bond is quite awkward, but I believe that the optimization will fix it. Now, before optimization, I'll add these groups as well. So just add the C double bond O and then OCH3. OH. Here is the OH and then a CH3 over here. So this group is complete, and then there was a CH3 at this position as well, which is still missing. So I'll just add it over here. Now this portion is complete, and just the aromatic part is remaining. We can add the aromatic part later on. First, let's optimize this molecule because of these weird bonds. If we optimize it and then add the aromatic, it would be better than just adding everything together and optimizing it once. So just optimize it once more. Uh, it says that the file already exists. So I'll just write 234 now. Close. Yes, run it. Okay, so this calculation is now finished, and the structure is optimized. Let's make it the way it looks like this 2D structure so that we can understand it easily. Here we go. Yes, so just focus on this six-membered ring. Here is the double bond, this one, and then C double bond OCH3 on the top, and then this hydrogen is above the plane, and then oxygen is right here, and then this oxygen is above the plane. You can see it is above the plane, it's towards you, and then the sugar, and then the whole molecule. So also check its stereochemistry. We go to view and stereochemistry, and now have a look. These both are S, this is S, this is S, and then have a look at the sugar. S, here is S, and then these both R, these are R, and then these two S, these two S. So it means we have designed the same molecule as shown in this chem draw figure, and you can see that this CH3 and has gone a bit far to minimize the repulsions. Now there is a little bit of issue here at position number 2 prime. The bond is wavy. It means that the stereochemistry is not known. So instead of adding this oxygen to the other hydrogen, I believe this would be very difficult to bring this oxygen near onto this position. So instead of changing this, we can change the aromatic ring. So if you want to design two of its diastereoisomers, one with one stereochemistry and the other with the other, what you can do is add this aromatic ring to this position and optimize, and then in a separate copy add it here and then optimize. So I'll just add at one position. I'll take this aromatic ring and add over here. Now you can see that it is showing it as R. So if I add it to that position, it will show it as S. So you can make it as per your convenience, and then final step, just add the hydroxyl groups. So 1 2 3 here and here. Now this molecule is complete, and you can see that it has the stereochemistry as it was in the ChemDraw figure. So I'll just copy it and take it to a new file and save it. Complete structure. I'll just save it, and this way you can draw very complex molecules. It is a bit tedious, and it takes a little bit of time to get used to these things, but it's step by step. It's not like you can draw all this molecule once. You have to go step by step to make refined structures, and structures with minimum energy, and which also get optimized in less amount of time. If you make a very bad initial structure, it will take ages to optimize. So this was all about drawing very complex molecules. I hope you enjoyed the video, and you would have learned a lot from this. If you have any questions, just post in the comment section, and I'll try to get back to you as soon as possible. Thank you very much for watching. Bye bye.